This paper proposes a novel algorithm for colorization of meshes. In a typical colorization session, the user starts by scribbling a few color strokes on the mesh. The system then automatically propagates the colors to the remaining mesh. Up until here, only a few colors were used to colorize the dress, the head, the legs, and the hands. The user can then proceed to fine-tune the colorization by adding more color strokes. For instance, now the torch is being colorized in brown and red. The whole interactive process takes only a few minutes. A fundamental assumption in mesh colorization is that similar vertices should be colorized similarly, unless they belong to different semantic regions of the mesh. Therefore, a mesh colorization algorithm should address two challenges. First, a technique needs to be devised for determining similarity of points. Second, colors should not bleed from one semantic region to another. We propose an algorithm that copes with these two challenges. Moreover, we apply our algorithm to paint reconstruction of ancient statues in archaeology. To measure the similarity between neighboring vertices, we present a descriptor that characterizes the geometry of a vertex and an effective similarity measure for these descriptors. Our descriptor is based on the spin image descriptor, which is modified such that it not only detects changes in the geometry, but is also less sensitive to noise. Color bleeding is handled through the definition of a new vector field on meshes, denoted as the feature line field. This solution makes it possible to avoid bleeding across regions without the need to segment the mesh first. Avoiding segmentation is important, not only because it is a difficult problem on its own, but also because the user should be allowed to color the mesh with any number of scribbles, regardless of the number of segments. Here we see how the bleeding effects disappear when the similarity measure is modified according to the penalties defined using our vector field. We apply our algorithm to archaeology, a domain that has recently been addressed quite extensively in computer graphics. The common perception of the great statues and buildings of ancient Greece and Rome is that they were all unpainted stone. However, lately researchers have been arguing that, in fact, at the era of their creation the statues were quite alive and full of color. Unfortunately, after centuries of deterioration, any trace of pigment had been taken off. Our colorization algorithm will be useful in the many archaeological paint reconstruction projects taking place around the globe.